We've already talked about 8.2 a little bit in terms of multiplying two polynomials, but 8.2 also talks about factoring polynomials as well. And so that's what we're going to talk about first. So in class, if you remember, at the very end of class, we talked about how I can model multiplying and factoring of two polynomials and of two binomials. So I took the two binomials, 2x plus 1 was, let's just say, is an example, and x plus 5 is my other binomial as an example. So what I do is I make a chart. So here's my chart, and I'm going to put, actually I'm not going to do 2x plus 1, I'm going to do 3x plus 1, and I'm going to do x instead of plus 5 minus 2. So we can talk about some negative answers here. So I'm going to put 3x plus 1 on the top portion. So I had, remember the green bars, those were my x's. So I have 3 of those. So here's my third x. So I've got 1, 2, and 3 x's. Okay, and then I have one yellow square left over. And so that represents 1, basically. Just represents the number 1. And then along the side, we're going to have 1x, one positive x. So this is an x. And I'm going to have 2 negative 1 squares, which represents my minus 2. Okay, so now all we had to do is multiply, and then this would tell me what my answer is. So I do x times x, which gives me a square that is the same as x squared. So this square is the same as x squared. X times x, x squared. Same situation here. X times x gives me another x squared and another x squared, x times x. So I have x squared, x squared. Then I have x times 1, so that is a 1x. So I just have a positive x here. Next, so I've done everything with x here, so I don't have to worry about that. Now I go on to the minus 1. Well, this minus 1 times x gives me a negative x here. And if I just keep going along, I get another negative x, another negative x, and then I get negative 1 times 1 gives me a negative 1. And since I have negative 1 in the next row, I get the same situation. So I have 3 negative x's and a negative 1 in each row. So now I just have to write down all the like terms. So I have 3x squareds. I have 6 negative x's, so that's a minus 6x. I have 1 positive x. And I have 2 negative 1 squares. So that gives me negative 2. Now I combine like terms, so this gives me 3x squared minus 5x minus 2. So if I were to multiply 3x plus 1 and x minus 2, that's the same as 3x squared minus 5x minus 2. Now the reason we did this first was so you can get the idea of how to model multiplication. Now what we're going to do is I'm going to give you the result, and you have to build, and we would have to build what's inside my rectangle here, and then figure out what goes here and here, and that gives me my answer. So we're going to go in reverse this time. So let's say I start out with the equation or the expression 2x squared plus 7x plus 6. So we're going to write these out just like we did before. So I have 2x squared boxes. There's one. There's two. I have 7 x boxes. Three, 4, 5, 6, and 7. And then I have 6 positive 1 squares. Okay, so here's 5 and 6. Okay, so there's my whole equation. Now what I want to do is rearrange all of these pieces kind of like I did my last one when in a rectangle. So I want to rearrange these in a rectangle. So let's try the first one. So I'm going to just copy what I have in these x squareds here. I'm going to copy them. Actually, I can just move them. Let me just move them. So I've got my x squareds there. And then I'm going to take 5 of my x's and put them next to that. Alright, there we go. And then I'm going to take the other 2 x's. Now I got to rotate those. If you guys remember, we rotated a little bit in the applet. So I'm going to rotate, there's one x and there's another x. So instead of, I'm just going to erase those so that we don't get confused. And then the 6 squares have to go in the remaining area. So I have 1, 2, 3, 4, and I have 5. So I've reached the edge here. You notice I've reached the edge. So my rectangle looks kind of like this. Okay, but I've only used 1, 2, 3, 4, 5 of my squares. I have 1 left over. I don't know why it's doing that, but it's cutting my thing off for some reason. Oh well, so I only have 1 square left. So because I have 1 square left and not none left, this orientation doesn't work. But if you notice, how would I write this up? This gives me an x plus an x plus 1, 2, 3, 4, 5. So this is really 2x plus 5. And then I have an x on the side and a 1 here. So this is x plus 1 on the side. So this representation is 2x plus 5 times x plus 1. But I have that 1 left over. Because I have that 1 left over, this orientation, this way of writing it or changing it around doesn't work. Okay, so let's try it again and rearrange it a second time. So let's see here. How am I going to do this? Okay. Okay, so here's my original orientation that I drew before with the 1 left over. Okay, so I'm going to rearrange these a different way. So if I went, because I went left last time, left and right last time, I'm going to change the order. So let's move this out of the way. Okay, and I'm going to move this one, this x squared down here. And so I've got the beginnings of my rectangle. So I've got my side here and my other side up top. Okay, now I just have to arrange everything. So I'm going to actually move this horizontal one. And I'm going to move the other vertical one. So I've got 5 in rows there. But if I order them this way, I'm not going to really be able to make a square with all I have. So I'm going to grab 2 of these that are up top and move them down. And then this horizontal one that's off on the bottom, I'm going to rotate it and place it here. You can get rid of that one. And then I'm going to move my yellow ones to fill in the gap. There's 1, 2, 3. And how many do I have left over? I have 3 left over. So again, this doesn't work. But just for the heck of it, let's see what my rectangle would be. Okay, so this is x plus 3 on the top, and on the side I have 2x plus 1. So this would be 2x plus 1 times x plus 3. If it worked, if it made a perfect square with nothing left over. I've got some leftover, so this doesn't give me the same as my 2x squared plus 7x plus 6. If I had no leftover, then that would be my answer. But I've got some leftover. So let's try it one more time and reorganize it. So let me get us some more of our stuff. And 4, 5, 6 squares there. Okay. So now I'm going to reorder it. So I'll just leave the 2x squareds there. And I'm going to leave 3 of my green x's up top. And I'm going to move the other ones below the x squared. So I'm going to rotate these vertical ones down here. I'm going to rotate those. So now we have 1 and 2. So there we go. And let's see, if I move my yellow squares, does that give me what I want? Oh, look at that. That last square fits in perfectly. So you notice, actually let me move this a little further down. When we draw my top and bottom, I have x plus 3, or you could say 1, 1, 1, which is still 3, and I have x plus 1 plus 1, which is 2. So this on the left side is x plus 2, and up top I have 2x plus 3. So my two binomials that multiply to give me this are 2x plus 3 times x plus 2. And the reason this works is because I have a rectangle with nothing left over. Now just to double check, I can multiply these out. So let's do that. So if I multiply 2x plus 3, this is my check. 2x plus 3 times x plus 2. That means I got to distribute, so I'm going to take the 2x times my x. That gives me 2x squared. Well, looks like we're starting off to a good start. Remember, we want 2x squared plus 7x plus 6. Then I do 2x times 2, which is 4x. Then I do 3 times x, which gives me 3x. And 3 times 2, which gives me 6. Combine like terms, I get 2x squared plus 7x plus 6. Is that what I wanted? Yes, it is. It checks out. So we know my answer is 2x plus 3 times x plus 2. So this is kind of what we did in class with the exploration portion of the lesson. You took either x squared or x and the ones or the negative ones, the negative x's and the negative x squared, to try and make a square or a rectangle with nothing left over, and then from there we got our binomials that multiplied. So that's all we did in class for the exploration. So let me just talk about some basic information that you needed in order to know how to do these, and basically kind of tell you what we're talking about. So anytime you want to do factor, actually I'm going to change color. Anytime you want to do some factoring, that's what this whole lesson is about, factoring. Your first step in factoring is you're going to find a common factor. Find a common factor. And really, one thing that I should say here is that when you're talking about factoring, this is reverse multiplication. So it undoes whatever you multiply by. Okay, so this is reverse multiplication. So let's look at an example here. If I have 4x cubed plus 12x squared minus 8x, I want to find the number and the variable, or the letter, that goes into all three terms. So however many of each letter and however many of each number I have, that's the thing that is my common factor. So first, we're going to look at 4x cubed. Now we're going to say to ourselves, well, how do I get 4? Well, that's 2 times 2. And how do I get x cubed? That's x times x times x. So 4x cubed is 2 times 2 times 2, or excuse me, times 3 times 3, wow, times x times x times x. So good, 4x cubed, 2 times 2 times x times x times x. Next we do 12x squared. How do I get 12? Well, I know that's 2 times 6, but 6 is also 2 times 3. So this is 2 times 2 times 3. And x squared is times x times x. Okay? So that's 12x. Now we need to look at negative 8x. How do I get negative 8? Well, I can multiply by 2, but then I'd have to multiply by negative 4. So then, I got to think about how do I get negative 4? Well, negative 4 is the same as 2 times negative 2, right? And then I multiply that by x. So now I'm going to circle everything that we have in common. So everything that we have in common, we have a 2 here, we have another 2, and then we have an x, and I don't have any more x's that they all have, right? I don't have any leftover x's here. There's nothing left. So that's all that I have in common. So the thing that they have in common is 2 times 2 times x. And 2 times 2 is 4, so this is 4x is my thing they have in common. That's my common factor. So your first step in factoring is look for a common factor. If they don't have anything in common, then you're going to look to factor kind of like what we did with the models in class, in the exploration. So your second step, if you have found a common factor, your second step is to factor out your common factor. Okay? So, in the last example, our common factor was 4x. So we had 4x cubed plus 12x. Actually, I'm just going to copy it. We had 4x cubed plus 12x plus, or excuse me, 4x squared minus 8x. So I'm going to paste that here. There we go. So again, our common factor was 4x. So I'm going to factor that out. And what that looks like is, I got to think to myself, if I pull out or undo multiplication by 4x, what do I multiply 4x by to get what I started with? So if I start with 4x, what am I going to multiply 4x by to get 4x cubed? Well, we can actually even go back to our common factor. If we pull out 4x, what do I have left? I have 2 x's. So that means I have x squared here. And we can check 4x times x squared is 4x cubed. So we're good. So that was a check part. So you don't really need to write that. That's just helping you remember what it is. And then I think about, what do I multiply 4x by to get 12x squared? You can again go back to your factor. We have a 3 here, and we have an x outside. So 4x times positive 3x gives me 12x squared. And last but not least, how do I get negative 8x? Well, I got to multiply by negative 2. Negative 2 times 4 is a negative 8. And then times x gives me negative 8x. So when you factor out your common factor, you're left with what you have remaining. Okay? So, real quick, another example. 3x squared minus 12x squared plus 15x. Might want to pause the video here just to kind of, if you want to try it on your own, that might be a good idea. And to help you try it and then check it with my work that I'm going to do here. So first I'm going to find my common factor. So I look at 3x squared, negative 12x squared, and 15x. Oops, this should be 3x cubed, I'm sorry. So we have 3x cubed, negative 12x squared, and 15x. So 3x cubed is 3 times x times x times x. Negative 12x squared is 2 times 2, which is 4, times 3, but one of them's got to be negative. Since we have a positive 3 in the top one, let's make the first 2 a negative 2. So I have negative 2 times 2 times 3, and x squared is times x times x. And then the last one we have 15. Well, 15 we know is 3 times 5. And x. So now I'm going to circle what I have in common. I have a 3, and then I have an x. So the only thing that they have in common is 3 times x, and that's my common factor. Next, I'm going to factor it out. So I factor out my common factor. What do I have left? Well, all I have left from 3x cubed is x squared. All I have left from negative 12x is negative 2 times 2, which is negative 4, and an x. So negative 4x. And then last but not least, I have a 5 left over, so this is plus 5. So that would be the fully well, not necessarily fully factored, but that's the first step. You factor out your monomial. Okay? Now, let's say you can factor what you've got left over. And in this example, we can. And so that's what when we pull out the concept we learned when we were factoring in class last time. We use the model to help us understand factoring. So anytime you have an expression that says something like x squared plus bx minus c or plus c, you could also have x squared minus bx plus c, Or you could have x squared plus bx minus c. And really, another one is x squared minus bx minus c, where you have both of them negative. So the first one is you have both positive. Then the second one is b is negative, c is positive. Next one you switch them, so you get b positive, c negative. And the last one you get both of them negative. No matter what, in any of these situations, for every situation in this that looks like this, you want to find the factors of the c, or in the last two cases, negative c. So you want to find the two numbers that multiply to give you c. And those two numbers we want to add to our b value. Or in the second and fourth example, we want it to add to negative b. Okay? So let me show you an example, a couple examples of this. So let's say we have p squared minus 3p minus 18. I want to find the factors of negative 18. But I also am going to look for the sum of the factors. So the first factors that come to mind are 1 and negative 18, right? 1 times negative 18 is negative 18. But if I add those together, that gives me negative 17. So is negative 17 the same as negative 3? No, so this one is not my answer. Then I'll try positive 18 and negative 1. Well, this gives me a positive 17, but that's still not 3. So my answer is not 17, or is not 18 and negative 1. Then we can try 2 and negative 9, but this adds to negative 7, not negative 3. So again, this is not my choice. If I do positive 9 and negative 2, this adds to positive 7, which again is not the right answer, because I have to have it add up to negative 3. So the next answer after 2 and 9 would be 3 and negative 6. 3 times negative 6 gives me negative 18. If I add them, hey look, I get negative 3. Since I get negative 3 here and negative 3 here, that means my numbers are 3 and negative 6. So this factors to my two binomials. P squared I get from p times p, if you remember. And then I'm going to have 3 and negative 6 here. So it's a positive 3 and a negative 6. So I have plus 3 minus 6. So my answer is p plus 3 times p minus 6. So I think I've given you guys plenty of examples and plenty of time to look over this. So if you have any questions, please fill out the form. And here is your multiple choice question. Go ahead and pause the video here and finish this question. If you have any questions, answer question number 5 in the form. And here is your free response question, rather. What this question is asking basically is, you first need to find the factors of the given equation, and those are your width and length, your length and width. Once you find your length and width, you can use those to find the perimeter. So hope you guys aren't going to hate me too much, and good luck.